Okay, so in this chapter or in this topic, we'll discuss the shapes of atomic orbitals. We have seen this picture in chapter 5.4, and based from the discussion on 5.5, we know or we have a deep understanding on these particular shapes. Going back on 1s, 2s, and 3s, if we have the s atomic orbitals, so we have an increasing size of the orbital if we have an increasing value of n, or the main energy level. So if we have n is equal to 1, n is equal to 2, and n is equal to 3. Just like in the p orbitals. So if we have 2 and 3. Take note, we do not have 1 p orbital. So why is that? 1 p orbital corresponds to the first quantum number n is equal to 1, and the second quantum number is L is equal to 1. So P is L is equal to 1. Okay, we do not have the combination of n is equal to 1 and L is equal to 1. So again, based from the discussion on chapter 5.5. Okay, so going back, if we have 2p and 3p, so 2p have smaller atomic orbitals than 3p. So this is also the same in the explanation with the s atomic orbitals. If we have 4p, 5p, and so on, and if we have 4s, 5s, and so on, we still have a larger atomic orbitals than the lower main energy level or lower first quantum numbers. So this also the same with the d atomic orbitals. Okay. So if we take a look at the s orbitals, so again, we have this electron distribution cloud. Okay, so if we have an s orbital or a sharp orbital, so we have this region of space inside wherein we see that most of the electrons, or most of the time, the electrons are found on that particular region. And we have this outer region wherein we still locate the electron, but it is not most of the time there is the electron, but still we look at the boundary for this. Okay, and we have the boundary surface as the one atomic orbital that we rely on. So again, based from the discussion a while ago, if we have 1s, so we see that we have a small region of space wherein we see the 1s electrons. For 2s, we still have this small, okay, but bigger than 1s electron cloud in which we see the 2s electrons, and for 3s we have a larger surface or boundary surface. For p orbitals, we have this. Okay, so I told you that we have in p orbitals we have two oblongated three-dimensional figure for the orbital. So we see in this electron distribution figure that most of the time the p electrons, for example we have 2p electrons, are found in this region of space and in this region of space, just like this one. So we have two egg-shaped figures. Okay, so what happens on the middle part? So the middle part wherein we do not see the electrons, so that is called a node. Node, or NODE. So these nodes, so we cannot have a okay, so there are notifications. Okay, so in these nodes we cannot see the electrons, but most of the time when electrons go from this one to this one, there is a change in the sign of the electrons. So this one, okay, so we cannot say that we have a positive or negative, but for just an understanding in a different charge. So for example, this electron cloud here has a charge of negative, and then if the electrons go from this one to this one, then this electron cloud is now the negative. So meaning to say that if this is negative, or in which the electrons are found, so this one is still a positive electron cloud wherein we do not see the electrons. But if the electrons go from this cloud to this cloud, this will become the negative, and then this will be positive. So that's it for the shapes of atomic orbitals. We will not deeply look in the d orbitals for now and f orbitals, since they are much more intricate. We have many nodes for the d orbitals and f orbitals. So we'll just try to discuss the s and p orbitals for now.